Okay, I welcome you to week 6 of our online facilitation for the course PHY 205. The course title is Introduction to Space Physics. And just by way of introduction, by way of revision, we started in the week 1 by introducing astronomy and satellite communication. Under that, we considered an introduction to astronomy, which is the unit 1 of module 1 in the first week. Then we proceeded to look at the history of astronomy, and then how astronomers work. Then we looked at unit 2, the solar system. Under the solar system, we learn our solar system and the motion of the planets. Then the unit 3 of module 1, we considered the satellite system. And under that, we looked at fundamentals of satellite system. We also looked at the basic characteristic of satellites. We also looked at improved space platform and launching systems. And then we look at transponder. Okay. Then week 2, we look at satellite networks. And then we learned that under satellite networks, we considered satellite orbit configurations, satellite network architectures, and general features of satellite networks. Then we proceeded to unit 5 of module 1, where we looked at satellite communications. Okay. Then under that, we look at the use of microwave frequencies, the digital transmission, compression, and routing. In details, if you look at the course material, you see this in more detail. It's explained more there. Then we looked at cable television and the mobile satellite communications. Then in module 2, we looked at the atmospheric science and the space environment. Under that, we look at in unit 1, introduction to atmospheric science, where we look at the scope of atmospheric sciences. And then we also looked at the meteorology and forecasting. And then we'll also look at weather and climate. What the difference? Weather actually deals with the condition of an area over a short period of time, while climate deals with the condition of a place, an area, over a long period of time. That can be considered the period of over 30 to 40 years. Okay. Then in unit 2 of module 2, we looked at the structure of the atmosphere. We look at the different layers, that's the atmospheric layers, and the relation to temperature. We also looked at the global air circulation and winds, and then the atmospheric pressure, and then fronts and their relation to baroclinic waves. And in unit 4 of module 2, we considered atmospheric dynamics, and under that we look at the clouds, atmospheric kinematics of fluid flow, and atmospheric dynamics, and also weather prediction, where we can use symbols and even the local observation to know actually what the weather will be. Then last week, which is week 5, we looked at the space environment, where is space, and the solar system. And then we looked at what? The cosmos, and the space environment and spacecraft. Okay, so today we will be looking at rocket engineering, space exploration, and okay. Okay, so I remain Dr. Cyril Lafoy, your course facilitator. So in module 3, as I said, we'll be looking at rocket engineering, space law, space exploration, and space law. Okay. Unit 1 of module 3, we'll be looking at rocket engineering. What is rocket engineering? Actually, I know rocket is not even the first time you're hearing the word rocket. You know, rockets are not the same as aeroplane. They are not the same as jets. You know, rockets are more faster than a rocket is a self-propelled device that carries its own fuel. Are you hearing me? A rocket is a self-propelled device that carries its own fuel, and as well as the oxygen or other chemical agent needed to burn its fuel. Rocket carries its own fuel, its own oxygen and other chemical agents needed to burn the fuel. Secondly, most rockets move by burning their fuel and expelling the hot exhaust gases that result. That's from burning the fuel. Now the force of these hot gases shoot out in one direction, causing the rocket to move in the opposite direction. I hope you remember your Newton's laws of motion, the third Newton's law of motion, which states that a body, for every action, there is an equal but opposite reaction. That is actually what happens. That's the principle behind which the rockets move. You know, that's why they said the force of these hot gases shooting out in one direction causes the rocket to move in the opposite direction. A rocket engine is the most powerful engine for its weight. So it means in the rocket, its engine is the most powerful part of the rocket. That's the most powerful for its own weight, the weight of the rocket. And you know what weight is? Weight can easily be defined as the gravitational pull acting on the body, which is expressed mathematically as W equals to the product of mass and acceleration due to gravity. Okay, so don't forget that. Now, what is the objective of this unit? At the end of this unit, you are expected to be able to, one, define a rocket. You should be able to know the definition of a rocket. And then two, you should also be able to explain the principles of rocket propulsion. You should be able to explain the principles of rocket propulsion. Now, you should also be able to state the Newton's third law of motion and derive the rocket equation. Hope you are hearing me. You should be able to state the Newton's third law of motion and derive the rocket equation. And fourthly, you should be able to explain the Tsotkovsky's rocket equation. Explain the Tsotkovsky rocket equation. And then 5, you should be able to explain the principles of the thermal rocket. Let me run through the objectives again. 1, you should be able to define a rocket. You should also be able to explain the principles of rocket propulsion. You should be able to state the Newton's third law of motion and derive the rocket equation. Then you should be able to explain the Tsotkovsky's rocket equation. And then you should also be able to explain the principles behind the thermal rocket. Now, let's look at the principles of rocket propulsion. Let's look at the principles of rocket propulsion. Human development has always been closely linked with transportation. Is that not so? That's why we either move by land, either move through the road, move through train, move through the air. But we must move. Transportation in the history of humans is very pertinent. The domestication of the horse and the invention of the wheel had a dramatic effect on early civilization. Even horses can be used to transport from one place to other, donkeys, other animals too. Now, most of the past millennium has been strongly influenced by sailing ship technology, through the ship in oceans, rivers, oceans, and seas. So both for war and for commerce, you move either for the purpose of war or for the purpose of commerce or for other, even for social reasons. In the 20th century, motor vehicles and aircraft have revolutionized transport. Rocket propulsion is the essential transportation technology for this rapid growth in human communication and exploration. From its beginnings in ancient China through its rapid development during the Cold War, rocket propulsion has become the essential technology of the late 20th century. Now, the principles of the rocket propulsion, as I said, involves the Newton's third law and the rocket equation. Now, as we have seen, the rocket had been a practical device for more than 1,000 years before Tsotkovsky determined the dynamics that explain its motion. Now, in doing so, Tsotkovsky opened the way to the use of the rocket as something other than an artillery weapon of dubious accuracy. In fact, he identified the rocket as the means by which humanity could explore space, go beyond the earth, go into outer space, see what is there, learn new things. with the rocket. Tchaikovsky made humans to understand that. Okay. Now, the rocket experiences a continuous propulsive force. So its flight will be different from that of a cannonball. In fact, while the cannonball is a projectile, the rocket is really a vehicle. Let me take that again. The rocket experiences a continuous propulsive force. So its flight will be different from that of a cannonball. You know the cannonball. If you don't know, check it again, Google it, and you see what the cannonball means. In fact, while the cannonball is a projectile, the rocket is really a vehicle. Now let's look at the Tchaikovsky's rocket equation. Tchaikovsky was faced with the dynamics of a vehicle, the mass of which is decreasing as a jet of matter is projected rearwards. So as we shall see later, the force that projects the exhaust is the same force that propels the rocket. Are we together? If the force that projects the exhaust is 500 Newton, then the force that propels the rocket must also be 500 Newton, but in the different direction, in an opposite direction. So minus 500 Newton in that case. Okay. Now, it partakes in Newton's third law that action and reaction are equal and opposite, where action means force. Then the acceleration force is represented using Newton's law, which is actually the second Newton's law, as force, F is equal to mv, where v is the velocity of the exhaust. That's the effective exhaust velocity. And then F, we know that is force in newtons, and m is mass in kilogram. Okay, so the thrust in this equation, the thrust of the rocket is expressed in terms of mass flow rate, m, and the effective exhaust velocity, VE. That's V subscript E. Okay, so so the equation released by the burning propellant appears as a fast moving jet of matter. Okay, now, and a rocket accelerating the opposite direction. Let me take that again. The energy released by the burning propellant appears as a fast moving jet of matter, and a rocket accelerating in the opposite direction. Newton's law can be applied to this dynamical system, and the decreasing mass can be taken into account using some simple different calculus. Okay, now the mass ratio, often written as R or A, don't forget that the mass ratio is usually written as capital R or capital A. It's just the ratio of the initial mass, m naught, to the current mass, m, where R, capital R, is equals to the quotient of m naught over m, where m naught is what? Initial mass, when the exhaust is not on, and then the m is the current mass. Okay. The thermal rocket. I believe by now we understand the Tchaikovsky's equation and what it means. So the thermal rocket, the rocket principle is the basis of all propulsion in space and all launch vehicles. the twin properties of needing no external medium for the propulsion system to act upon and no external oxidant for the fuel enable rockets to work in any ambient conditions, including the vacuum of space. So rockets can actually work in any ambient condition, including vacuum of space. So you can imagine that because it carries its own oxygen, its own light, a vacuum. So it's actually a space without air or light. Now, the thermal rocket is the basis of all launchers. Almost all space propulsion, although some electric propulsion uses a different principle. The thermal rocket motor is a heat engine. Yeah, I hope you remember your heat engine in thermodynamics. The engine converts the heat generated by burning the propellant, fuel, and oxidizer in the combustion chamber and into energy of the emerging exhaust gas. Now the momentum carried away by the exhaust gas provides the thrust which accelerates the rocket. As a heat engine, the rocket is no different in principle from other heat engines, such as the steam engine or the internal combustion engine. The conversion of heat into work is the same. Whether the work is done on a piston or on a stream of exhaust gas. Let me take that again. The conversion of heat into work, heat energy into work. I hope you remember that energy and work are actually the same because work is the ability, a capacity of a physical system to perform work. So whether the work is done on, they are the same, whether the work is done on a piston or on a stream of exhaust gases. And the basic configuration of thermal rocket. Configuration of thermal rocket. A liquid fuel rocket engine consists of a combustion chamber into which fuel and oxidant are pumped, and an expansion nozzle which converts the high pressure hot gas produced by the combustion into a high velocity exhaust stream. Now it is the expansion of the hot gas against the walls of the nozzle which does work and accelerates the rocket. Okay, so a solid fuel motor operates in the same way, except that the fuel and the oxidant are pre-mixed in solid form and are contained within the combustion chamber. You understand? The solid fuel motor operates in the same way, except that the fuel and the oxidant are pre-mixed. They are pre-mixed in solid form and are contained within the combustion chamber. Normally, the combustion takes place on the inner surface of the propellant charge. The exhaust nozzle is identical to that in the liquid fuel motor, and the principles of operation are the same. In this module, we shall make little distinction between the solid and liquid fuel variants of the thermal rockets. Now we can see in this figure on the screen, we have two types of fuel rockets. The first one is the liquid fuel rockets, and the solid fuel rocket. Okay, now the liquid fuel rocket, you can see the fuel and the oxidant coming in, and then combustion takes place. Then hot gas at high pressure produced, then expansion takes place. Well, in the solid fuel rocket, we can see two propellants there, and in between them, combustion is taking place. Then hot gas is being released, and then expansion at high velocity exhaust. So high velocity exhaust is going out, gas is going out this way, then the rocket is being propelled forward. Okay, so will be want us to look at okay. Now let's see what is your self-assessment exercise today. The self-assessment exercise for this unit is you should briefly discuss the principle of rocket propulsion. You should briefly discuss the principle of rocket propulsion. Okay, and then in conclusion, we have learned that rocket propelled vehicles are the essential transportation technology for this rapid growth in human communication and exploration. In addition, the thermal rocket is the basis of all launchers and almost all space propulsion. In summary, let's look at what we learned today in this unit. We have learned that a rocket is a device which propels itself by emitting a jet of matter. A rocket is a device which propels itself by emitting a jet of matter. Now, the momentum carried away by the jet results in a force acting so as to accelerate the rocket in a direction opposite to that of the jet. I may want to ask you now, I hope you can explain acceleration, velocity. Hope you know how to explain that. Let's say velocity can be defined as what? Change in displacement per time. Velocity and speed are not the same. They may have the same SI unit, but one is a vector quantity and the other is a scalar quantity. Speed is actually a scalar quantity. It has magnitude, but no direction. While velocity is a vector quantity, it has both magnitude and direction. Now, acceleration is actually the change in velocity over the time taken. Okay, change in velocity over the time taken. Please remember these basics. Very, very important. Now, a rocket carries both. We also learned that a rocket carries both its fuel and its oxygen, and needs not to intake of. It needs no intake of air to operate. No. So a rocket can function in a vacuum, and in fact works better in a vacuum because air pressure retards the exhaust and reduce the thrust. Okay. Now, a rocket principle is the basis of all propulsion in space and all launch vehicles. And you could remember that in the third Newton's law of motion. What is the third Newton's law of motion? It says for every action, there is equal but opposite reaction. So make sure you know that it's actually the basis of this rocket propulsion. Then the thermal motor is a heat engine. Now, what is a heat engine? Heat engine actually combines the heat generated by burning the propellant fuel and oxidizer in the combustion chamber and into energy of the emerging exhaust gas. Okay. Then a liquid fuel also learned that the liquid fuel rocket engine consists of a combustion chamber into which fuel and oxidant are pumped, and an expansion nozzle which converts the high pressure hot gas produced by the combustion into a high velocity exhaust stream. While the solid fuel rocket has two propellant with the combustion taking place between the two propellant. So please always remember the differences, and remember to do your self-assessment exercise. I want to just introduce rotation of the earth. Okay. Rotation of the earth. Okay. Now, as a way of introduction, in an isolated system, the amount of rotation or revolution known as angular momentum does not change. That is in an isolated system. Okay. Now, the angular momentum of a rotating object depends on its speed of rotation, its mass, and the distance of the mass from the axis of rotation. Okay. Now, thus, when an ice skater draws his or her arms in, thereby bringing the distribution of mass closer to the center, the skater spins faster. The amount of angular momentum is conserved. And then the speed of the Earth's rotation is best measured by studying historical records of eclipses. A total solar eclipse is so dramatic that even written descriptions from thousands of years ago can be interpreted to show whether a total eclipse occurred at the writer's location. So you can imagine that. Now, the objective of this unit is actually that at the end of this unit, you should be able to explain the Earth's rotation. You should also be able to explain how a spacecraft gets into space. And you should be able to define parking orbit. Then lastly, you should be able to show how to calculate the path of the spacecraft in terms of the total angular momentum. Most of this is very clearly explained on the course material. And I expect you to check and learn the derivations, the step-by-step explanation. Okay, so now, orbit and space flight. Orbit and space flight. If we leave the problem of exhaust velocity and mass ratio for a moment, we shall turn with Tsiolkovsky to the question of how to get into space. This involves gravity, don't forget, and the motion of vehicles in the Earth's gravitational field. Now, common experience shows that with a cricket ball, for example, tells us that the faster a body is projected upwards, the further it goes. Okay, so the science of ballistics That's ballistic missiles, tells us that a shell with a certain velocity will travel furthest in a horizontal direction if projected at an initial angle of 45 degrees. Okay? Now, orbits. Having introduced the topic of orbits, we can now look into the motion of spacecraft, which always move in orbit and not in straight lines. Okay, always move in orbit and not in straight lines. Gravity cannot be turned off. Gravity cannot be turned off. A spacecraft does not leave the Earth's gravity. It would be more correct to say that it gives in to the Earth's gravity. So the motion of a spacecraft is that of a body with a certain momentum in the central gravitational field. Okay. So I want you to check the course material to look at in details the Earth's rotation. Just as a way of assignment, read it on your own and understand that you are able to answer all the objectives, look at the self-assessment, and also look at the summary and then the conclusion. With that, I believe this course will just be a walkover for you. And I know you will understand the course very, very well. So I think we'll call it quit for today. See you next week, the same time, Monday, 10 a.m. sharp. So read your books. I wish you all the best. Thank you.